how do we know if we're using a compiler, there's a deterministic, outcome, that the language specifies. That's what computer language really works as, is, a set of rules of how to get from this high level description to this set of instructions in machine code. So
I think,
the LLM puts a quite sophisticated additional layer in the midst of that process of translation. You were going to say something, sorry.
yeah. Oh, no, no, sure. Yeah, I find that this is actually where the spec comes in and really shines, I find. The specification of being very clear about, when this happens, this must happen.
Yes.
This kind of thing. Because, sure, it's just text. It starts out as just bullet points. Like, these are just bullet points in a README file, essentially.
Yeah.
But so how does the agent then turn that into functioning code, the production code that's well tested and actually does the thing that we said? So this is actually where I'm finding that testing techniques that were that have existed for some time now are being used to really shine in order to keep the agent honest, frankly, like to make sure that it's doing what we had agreed on in the requirements.
Yeah.
A whole bunch of testing techniques I'd mentioned, where having it run, be able to mock out, to create simulators, not mocks, but like functioning simulated versions of dependencies. But the one that I think is particularly interesting that we implemented in Kiro is called property-based testing. There are frameworks out there that there's in different programming languages that do this property-based testing technique, which makes it so you define these invariants in the system, and it will verify that invariant during any permutation of input and state transition within that. So what do I mean? I guess if you were to be implementing a traffic light system, so let's say what is the most important job of a traffic light system? That at most one direction is green. That's, I think, the most important invariant. That sure, you might have it no direction being green, but if there's more than one, that's a big problem. And so that's an invariant that would be captured in the requirements in the spec that would say it would be an important one to hash out. And I would read the spec to make sure that was in there. But then from that, Kiro can generate these property-based test cases, which generate these frameworks are pretty similar. They operate to generate a bunch of input, bunch of random exhaustive inputs of the state space, and then they check these invariants to make sure that as it feeds those inputs of sequences of timing of the lights and so forth, and when people press the walk button to go across, for example, and verify that the critical invariants hold during each of those generated inputs. So this is a technique that's been around for a long time, but it really comes into play nicely here. Just like other testing techniques that are pretty typically pretty expensive to implement, like worth it in some cases, but expensive to implement. Like I was talking about the mocks and simulators, also TLA plus testing, like TLA testing or formal verification of the behavior of a distributed system. This modeling is something that we do in our kind of Paxos implementations under the hood for things like DynamoDB and other storage things to make sure we really get it right. These are things that have been around a long time. They're fantastic, but they take a lot to implement, and then to verify that the code matches the model and everything is a lot. So those techniques that were for testing that were pretty difficult to do before, maybe take a lot of time, maybe not. Some of them aren't always the highest priority for every project. Those are now more in reach. So to me, it's actually setting up projects to be able to take advantage of all these testing techniques that have been around for so long is actually what makes the quality better when using this kind of spec.
Yeah, I'm very happy you said that. I think I understand more what you're describing now. So that's much closer to what I think of in these circumstances. So I'm kind of fairly wedded to behavior-driven development as a way of specifying. We call the tests that we write specifications in BDD, and so those are the specifications that seem to work well. As you say, there are other kinds of tests. I suppose my fear is that there's a lot of people that I've heard this conversation a lot talking about spec-driven development, where it's dismissed from kind of agile practitioners, and it's talked about from other people as being a kind of waterfall. And I think there are some severe dangers there, because waterfall is absolutely terrible at getting any feedback. And it seems to me that an important part of software development is the ability to iterate, experiment, and learn. And that seems, it seems to me that one of the reasons why we design programming languages the way that we do is as tools that allow us to explore solution space given a problem. And so we can explore the problem, find out better and better solutions until we get, close to something real.
Mm-hmm.
And that seems really important. And so that seems important that we build into our use of these tools, to me.
That's right. And spec-driven development is really, it is not particularly waterfall-y, actually. It's just a very mini one. Like when I am doing building a system or adding a feature to that system, I'll just make a new spec. It's like, it's like take a task that isn't going to be the most trivial thing in the world. I'm not changing the color of a button or something like that. I don't need a spec flow for that. But if I'm going to add a feature, I do a new spec. This isn't about updating one kind of serious document that keeps everything in order about everything in the system. I don't do that as a part of the spec-driven development flow. That's sort of separate context that's useful to help kind of feed agents to understand what a system is all about. Besides that, but I do check in all of the specs into source code of everything that we work on. So the specs are actually a pretty minimal framing of agreeing on what this thing is going to be. It might be a whole system, like it might be a whole. For example, I made an MCP server that could query some application logs from my S3 bucket. Just a pretty simple thing, but that was just one spec. It one-shotted that whole thing, and that was pretty using some of the services that we have in AWS to help build. But these specs don't have to be gargantuan waterfall and get in your way. These are pretty natural kind of extensions of. Okay, I get frustrated when I don't use it. Actually, I get because I might find that I come back 20 minutes later to the IDE to see what it's working on. And it might be like doing a refactor that I wanted it to have nothing to do. I didn't want to do in this upgrade right now. It just kind of went down a path when it ran into some dead end, and it felt like it needed to refactor everything. So I just get pretty frustrated when it just goes off and wanders around. Like by having this kind of task list and plan, it's just a little bit of upfront to then have much nicer results.
Yeah. So going back to the war story that we started with of the 30 devs, however many months it was, plan that you brought down, that must mean that per person you're creating a lot more stuff. And so it seems to me that our future and where we're going is that we are moving. No, I'm going to correct myself. I never really thought that writing code was the bottleneck, but there seems to be an assumption in the industry that it is. But we're moving away from code being recognized as the bottleneck to other things that were always the bottleneck, but verification, validation, the ability to get this into the hands of users and determine whether it's making sense or not. Those sorts of things become more important. And so given the way that you talked about and described your approach, you've kind of talked about, if you'll forgive me, it seems to me that you've talked about a mix of things. You've talked about specifications as reasonably high-level behavioral things, what I want, the outcome that I want from the system. And you've also talked about more technical things. I'm thinking of this class or this library, those sorts of things. So if you're producing, more stuff, more code, how are you staying on top of those things? It seems to me that you're flying at two different levels of abstraction in that. I just wonder if you could talk to that a little bit and explain the balance of those things. And, why do you need to be worrying about both of those things? I agree with you that you do. I'm just trying to understand how you see it.
Sure. Yeah. This shows the rate of kind of pull requests coming in per developer. The marked increase, I think, shows the importance of things that were particularly healthy for teams to be doing before, but now it makes them just that much more important. So having thorough pre pull request, pre code review, if you will, testing, to be able to do as much, have the agent prove itself before that code review and before that merge, because developers spend, I find developers on teams that are going fully this way, maybe spend a small amount of time writing code and a lot more time doing other things like reviewing it. And so you want it to, if I'm spending time reviewing code, I want to make sure it's verified output first. I don't want to review code and then run some other tests later and find that it wasn't actually right. So I kind of want to have that up front. So we focus on pushing, if you will, like a shift left of pushing as much testing as possible pre-commit. Because the moment, if you think about a team of developers, each having multiple kind of teamwork sections open, each with a coding agent working on a different task, maybe in the same or similar code base, that's a lot of happening at once. A lot of opportunity where if something is pushed, so actually merged in to the remote the code base, and it fails later on in the release process, like maybe after deploying to an environment and having integration tests fail there, well, that's a big pipeline stall that's much more expensive in terms of the team throughput than before. Now there's a matter of, okay, how do we fish that out and figure out which commit might have broken the integration test? So we really try to push all of that as much as possible pre-commit. So that's a big part of it.
This clip was taken from my podcast, The Engineering Room with Dave Farley, a monthly podcast with some of the brightest minds in software engineering. You can find full episodes on all your favourite podcast platforms, including Spotify, Apple Podcasts and Amazon Music. Your support helps us to bring you these regular episodes, so please leave your positive review on your preferred podcast platform to help us to continue to grow and bring you great guests and their insights. Thank you very much for listening.